You're tuned into All This Math. This is Professor Parker, and we're about to get into one of my favorite things to do in math, right? Specifically in trigonometry. One of my favorite things to do in trigonometry, and I'm going to tell you why in a moment. But before we get into that, I want to make sure that you're subscribed to the channel, you're subscribed to the YouTube channel, and also go ahead and turn on the post notifications too while you're at it. And because I'm putting content on Instagram now too, subscribe to the Instagram page. Follow me on Instagram at All This Math. All right, so now check this out. This is one of the favorite things I like to do in trigonometry. I'm gonna tell you why. Because this, I like to think, models verifying trig identities or verifying trigonometric identities, models social science, it models social reality, it models real life situations, right? Well, all math models real life situations, but this is one of the ways. This is a way of modeling a real life situation that is often overlooked, because a lot of people go through life and thinking in terms of, and a lot of people go through life thinking that one thing don't got nothing to do with the other. They don't see the connection. If you draw a connection, sometimes they accuse you of reaching, right? But what this does is it shows you how mathematically we can prove that two things are in fact equal to each other. Two things that don't look nothing like each other actually can be proven to be mathematically equal to something else by the use of the transitive property over and over again, right? And that's basically what happens in social situations and in our social reality. Like a lot of times, like one thing may be a cause of something else, or one situation in the community within the system that we live in might end up causing something else that affects something that we deal with on a daily basis. But because it's not marketed that way, or because the mainstream media don't talk about it that way, we think one thing don't got nothing to do with the other. Well, some of us think one thing don't got nothing to do with the other, but I'm here to tell you, a lot of times things are connected. Just because we haven't done the deep analysis to see the connection, don't mean it's not connected. So anyway, let's get into this, right? With verifying trig identities, we have 2 times the cosine theta minus 1 is equal to cosine of the 4th power of theta minus sine of the 4th power of theta. Now those two things look nothing like each other, right? This over here looks nothing like that. I mean, you see a cosine right here and a cosine right there, but besides that, they look totally unrelated. So this is what I'm gonna do first. I'm gonna try to break down the right-hand side, right? Now, in algebra, we learn how to factor. Learn how to factor in algebra. Now, you probably took an algebra class before you got to trigonometry, right? I'm sure you did, right? So you know how to factor a perfect square binomial, or what we call a difference of 2 squares. This to the 4th power is not to the 2nd power. Usually we say it to the 2nd power, but the 4th power is still a perfect square, right? Because any exponent that is an even numbered exponent is a perfect square, right? We have to also know that. So this is a difference of 2 squares. This is a square, this is a square, and it's a difference because there's a minus sign in between them. So we can factor them a certain kind of way. So we break this down like this. We take the square root of cosine to the 4th. We take the square root of cosine theta to the 4th power, which is cosine squared of theta, and the square root of sine theta to the 4th power, which is sine squared, right? And I'm gonna make 1 plus, and I'm gonna multiply that by the same thing, except for instead of a plus sign, I'm gonna have a minus sign. Boom. I almost ran out of space, but I'm cool. So look, I took the square root of this term, right, which is this and this. I took the square root of that term, which is this and this, right? And I set it up like that. Now, before I move on, I want to mess with the left-hand side. On the left-hand side, and this is something else too that you need to keep in mind. There's something that's called a trig identities cheat sheet. Now, if you don't have one in your textbook, go online, go on Google and do a Google search of Trig Identities cheat sheet, right? It's called a cheat sheet because it's got a lot of formulas that you'll use on a regular basis in any trigonometry class, right? And it's good to have that. You should do your best to try to memorize most of those formulas. Your teacher may or may not let you use them on an assessment or a test or a quiz, but that's a good reference. You should have this type of reference whenever you're verifying trig identities, in case you don't have them all memorized, right? Trig identities cheat sheet. You want that. You need that, right? On the trig identities cheat sheet, you'll find something called the double angle formulas, right? This is one of the double angle formulas, right? Well, this is equivalent to one of the double angle formulas, 2 cosine squared of theta minus 1. Now, 2 cosine squared of theta minus 1 is equivalent to a couple of things. One of the things that it's equivalent to, which is very relevant in this problem, is the cosine squared of theta minus sine squared of theta, right? So now, I see cosine squared of theta minus sine squared of theta, but over here, this is not equal to this because this is not the same thing over here, right? That's cosine squared of theta minus sine squared of theta, but that's cosine squared of theta plus sine squared of theta. So now I gotta think, what do I know that's equivalent to cosine squared of theta plus sine squared of theta? And again, if I didn't know this, I would go to my trig identities cheat sheet and I would look, right? There's a section on that trig identities cheat sheet that says Pythagorean Identities. Now, yeah, Pythagorean Identities, Pythagoras, all that. We know he studied in the ancient Kemet under, African ancestors, and he learned a lot of things about geometry and whatnot. But, he gets the credit for that. But that's a conversation for another time. But as long as you know better, right? You know that came from Africa, all right? But anyway, on the trig identities cheat sheet, we got the cosine squared of theta plus the sine squared of theta is equal to 1. That's one of the Pythagorean identities. Cosine squared of theta plus sine squared of theta is equal to 1. So watch what happens. This whole thing right here turns into a 1. And this is still here. Cosine squared of theta minus sine squared of theta. And now we just verified the identity. Because cosine squared of theta minus sine squared of theta is definitely equal to 1 times cosine squared of theta minus sine squared of theta. And that's about it. So this problem was actually kind of light. It didn't even take up a whole lot of board space. But yeah, the key, familiarize yourself with all the trig identities. If you don't have one of these cheat sheets, print one out, go online, do a search, right? For the Trigonometric Identities cheat sheet, or just type in Trig Identities cheat sheet, right? It's on there, right? You'll see a lot of different examples of it too, right? You want to print that out. You want to keep that with you. Keep that in your notebook at all times so you can refer to it back over and over again, right? So you become more and more familiar with all these different trig identities. You also need to apply your skills from algebra for factoring. Factoring applies here. In order to prove that the left side does in fact equal the right side. Now, like I said, I like this because initially looking at this, you would think 2 cosine squared of theta minus 1, like that looks nothing like this over here. So how are they going to be equal? We just proved how they're going to be equal. Because this is equal to this, right? And this over here is equal to this. And then we knew that this part right here was equal to 1. And when you multiply 1 times something, you're left with just that something, which we got right here. So you see how math really exposes how a lot of things that don't look related are very related. So that's another reason that math is very helpful to us, because we can take those principles and we can apply them to our everyday life. Because sometimes 2 things look like they have nothing to do with each other, but they actually do, So, like I said earlier in the video, if you haven't subscribed to the channel already, please go ahead and subscribe to the channel. Like the video if you found it to be helpful. Share the video, send it to some other people, let people know what we're doing over here, all this math. And as I always say, do remember, there's all this math all around you. Peace.